An architect designs a theater with 15 seats in the first row, 18 in the second, 21 in the third, and so on. If the theater had a seating capacity of 870, how many rows must the architect use in his design? This is a word problem, and the first part of the word problem is to translate it into mathematical expression or mathematical terms so that hopefully we will get an equation from the given information, and then we will solve the equation to obtain the answer. The first row has 15 seats, so a sub 1 equals 15. Give us a name. We know that this is going to be some sort of sequence because we have the first row, second row, third row, and so on. The subscript denotes the row. So a sub 1 denotes the first row. A sub 2 denotes the number of seats in the second row, which is 18. A sub 3 equals 21. And so on, meaning that there is an apparent pattern. The sequence is 15, 18, 21. Since the common difference, the difference between any two consecutive terms is 3, 18 minus 15 is 3, 21 minus 18 is 3, we know this is going to be an arithmetic sequence. And the arithmetic sequence has the formula a sub n equals a plus d times n minus 1. A is the first term, 15. D is the common difference, 3. And so we obtain the formula for the nth row. This is how many seats there are in the nth row. We were told that the theater has a seating capacity of 870, meaning that we do not know how many rows there are, but if we add the number of seats in all of the rows, the total should be 870. Using what we learned from the sum of an arithmetic sequence, which is S sub n, this is the sum of the first n rows. There are n rows total in the theater. The sum is n times the initial term, which is the number of seats in the first row, plus a sub n, which is the number of seats in the last row, divided by 2. This is the formula for the partial sum of an arithmetic sequence. We're looking for n because we're looking for the number of rows. The total has to be 870, so we replace the sum with 870. We don't know what n is, so we will rewrite it, but we know a. A is a sub 1, 15, and the last term, which is a sub n. But we can't leave a sub n. We don't know what a sub n is, but we cannot use a sub n because a sub n is a variable and n is a variable. To solve the equation, we need to have only one variable, preferably. We see that a sub n is the expression here, so we would replace it with 15 plus 3 times n minus 1. Don't forget to divide it by 2. There is only one unknown in this equation, and that is n. If we solve for n, then we'll get the answer. N is the number of rows. First, we see that we can multiply 2 to both sides of the equation to get 870 times 2, which is 1740, equals n times 15 plus 15 is 30, plus distribute 3, we get 3n minus 3. And we multiply 2 to both sides of the equation, so the 2 cancel the 2 already. Simplifying this further, we have 1740 equals n times 27 plus 3n. And so this is 1740 equal 27n plus 3n squared. And we recognize that this is a quadratic equation, and so we would zero this out. 3n squared plus 27n equals 1740, or 3n squared plus 27n minus 1740 equals 0. Now, it is better to simplify this before we solve this equation. And we see that we can divide by 3 both sides of the equation. 3n squared divided by 3 will give us n squared. 27 divided by 3 will give us 9. So 27n divided by 3 is 9n. Minus 1740 divided by 3 is 580. 0 divided by 3 is 0. We either factor this or use the quadratic formula to solve for n. Regardless of which method we use to solve it, we will get n equals negative 29 and n equals 20. Again, we can either factor this or we can use the quadratic formula to get 2 n's. But n is the number of rows, so we cannot use negative. Therefore, we would need to have 20 rows to make sure that there are 876 in the theater. It is a big number, but we can factor this by trial and error. Although if you don't want to use trial and error, then we can use the quadratic formula to solve this. N equals, remember the quadratic formula is negative b plus or minus the square root of b squares minus 4, a is 1, and c is negative 580 divided by 2. And if we do this, we'll get negative 29 for one solution and n equal 20 for another solution.